before time had a name, before space had direction, before even the idea of nothing made sense, something happened. Something so violent, so unimaginable, that it gave birth to everything you see around you: stars, galaxies, light, time itself. We call it the birth of the universe, but here's the terrifying part. Science still doesn't know what actually came before it. Was our universe created from absolute nothingness? Or was it born from the death of something else? And what if this universe is not the first one? For centuries, humans believed the cosmos was eternal and unchanging. The sky felt permanent, infinite, untouched. Then one day, a telescope on a quiet mountain in California shattered that explanation forever. Suddenly, the universe wasn't still. It was running away. Every galaxy, every cluster of stars, all moving apart as if space itself was stretching. This meant one thing. If the universe is expanding today, then in the past it must have been smaller, denser, hotter. And if we rewind far enough, everything, space, time, matter, collapses into a single point, a moment where the laws of physics break. A moment we call the beginning, but beginnings are strange things. Because in nature, nothing ever truly begins from nothing. So what really happened at the start of everything? Was the Big Bang the first moment of existence? Or just the latest chapter in a much older cosmic story? Tonight, we journey back not just to the birth of our universe, but beyond it, to the ideas that suggest our universe may have been born from another universe, or trapped in an endless cycle of cosmic death and rebirth, or even floating inside a higher dimensional reality we cannot perceive. This is not science fiction. These are real theories proposed by some of the greatest minds alive today. And by the end of this video, one question will haunt you. What if our universe is not special at all? The discovery that changed everything began in the early 20th century. Astronomer Edwin Hubble observed that the faint clouds scattered across the sky were not part of our galaxy at all. They were entire galaxies of their own, millions of light years away. But the true shock came next. These galaxies weren't stationary. They were moving, and not randomly. Almost all of them were rushing away from us. The universe was expanding. This single observation forced scientists to confront an unsettling conclusion. If space is expanding now, then once upon a time it must have been compressed into an unimaginably small state. This idea became the foundation of the Big Bang theory, according to it. The universe began as an extremely hot, dense condition, a cosmic singularity where space and time themselves were compressed beyond our understanding. There was no before in the traditional sense, because time itself emerged from this event. As the universe expanded and cooled, energy transformed into matter. Elementary particles formed. Gravity pulled them together. Atoms were born, then molecules, then stars and galaxies. Within just a few 100 million years, the first cosmic structures illuminated the darkness. Our universe was alive. Yet this elegant theory carried a troubling flaw. If the universe began in a violent explosion, then matter should have been scattered unevenly, chaotic, clumped, unpredictable. But when scientists looked at the early universe, they found something strange. It was almost perfectly smooth. To explain this, physicist Alan Guth proposed the theory of cosmic inflation. According to this idea, the universe experienced an extremely brief but powerful burst of expansion, faster than the speed of light, moments before the Big Bang fully unfolded. This inflation stretched space itself, smoothing out irregularities and setting the stage for the universe we observe today. For many scientists, this explanation was enough, but not everyone was satisfied. Physicist Martin Bujold questioned the idea of a singular beginning. In his view, a singularity appearing from nothing made no sense. Instead, he proposed a radical alternative. Time itself may be quantized, flowing in tiny steps rather than smoothly. If so, the Big Bang may not have been a beginning at all. According to this model, the universe could collapse back into a dense state, only to bounce forward again, creating a new universe. Each cosmic birth would be the death of the one. Before it, an endless cycle of universes, and then came an even more unsettling idea. Physicists Neil Turok and Paul Steinhardt suggested that our universe might exist on a higher dimensional surface called a brane. Multiple universes could exist side by side, separated by dimensions we cannot perceive. When these branes collide, the energy released could ignite a new Big Bang. In this view, our universe is not unique. It is one of countless worlds, born from collisions in a higher dimensional reality. These ideas stem from string theory and M-theory, frameworks that attempt to unify all forces of nature, requiring up to 11 dimensions of space. For now, none of these theories can be proven, but each one tells us the same haunting truth. The universe may be far older, far stranger, and far less singular than we ever imagined, and perhaps our universe is just one moment in an endless cosmic story still unfolding.